Find the linearization of f of x equals the cube root of x at a equals 8 and use it to approximate the cube roots of 7.5 and 8.4. So if we want the linearization, we're going to need the derivative of f. And since f of x equals x to the 1/3, that's going to end up giving us 1/3 times x to the negative 2/3. And in particular, we're going to need this derivative at 8 because that is the value we're looking for the linearization about. So that's going to be 1/3 times 8 to the negative 2/3. Now we know that a negative exponent brings something to the denominator. So that's going to be 1/3 times 8 to the 2/3. And to evaluate 8 to the 2/3, we need to take the cube root of 8, which is 2, and then square that, which is 4. And so that ends up being 1/3 times 4, which is the same as 1/12. And so we have, for the linearization, we've got our function evaluated at 8, and we know the cube root of 8 is 2, plus f prime at 8, which is 1/12, times x minus 8. And so that's going to be 2 plus x twelfths minus 8 twelfths. Now 8 twelfths is the same as 2/3, so we've got 2 minus 2/3. That is 1 1/3, which is 4/3. So we've got 4/3 plus x over 12. You could leave it like that if you want. You could also write it as a fraction with 12 as the denominator. X twelfths is x twelfths, and then 4/3 is the same as 16 over 12. So we end up with x plus 16 over 12. And we want to use that to approximate the cube root of 7.5 and the cube root of 8.4. So the cube root of 7.5 is approximately 7.5 plus 16 over 12, which is 23.5 over 12. And I am going to be lazy and use a calculator here, but we could go through and do this long division to get an approximation without a calculator. So this still unlocks the ability of us to get an approximation of a cube root without needing a calculator. I'm just using a calculator out of sheer laziness. I don't want to have to write out a long division problem. And so I get approximately 1.95833. And if we use a calculator to get the cube root of 7.5, we end up with approximately 1.95743. So this is at least close to the nearest hundredth, which isn't that bad since this is a whole half of a number off of 8. That's pretty good for something that is a little bit further away from 8 than the other examples we've done so far were far away from 1. So that's pretty good. We can also figure out an approximation for the square root of 8.4. It's going to be about 8.4 plus 16 over 12, which is 24.4 over 12, which is 2.03333, repeating. And if we were to use a calculator to get this square root of 8.4, we would get approximately 2.03279. And again, we are good to the nearest hundredth. So these are pretty good approximations. This is a very useful tool.